Hi, welcome to the Shiko Math differential equation problem solving section. So today we're going to solve the differential equation problem we're going to solve is the first order differential equation problem. So here is dy over dx minus 1 over xy equal to 1 over x cubed y squared here. All right, so now let's take a look. How do we solve it? All right, before we solve these equations here, let's first review about what is the Bernoulli equation, which one is a very useful and powerful equation for solving the first order differential equations here. Okay, so now let's take a look. All right, so for the Bernoulli equation, let me write over here so we can reference back. So the Bernoulli equation is telling you is the dy over dx. Okay, so plus some function of the x, px, and the y, and will be equal to qx. Okay, so and yn. So if my differential equation satisfy the Bernoulli equation, then I can use the how to solve in the use like to find the integration factor, those things to solve it. So let's take a look at our problems here. This is the dy over dx. Now the px here, this is my px, right? Okay. And then the qx is here. So this is my qx. All right. Also, by reference to the Bernoulli equation, so for this one here, my n here is what? This is my n. N is what? N is 2 here. Okay. So now remember when we're solving the Bernoulli equation, the key tricks here is we define the variable. We say y is equal to what? Y equal to 1, then is 1 minus n. So for our problem here, the n is equal to 2. So this will be 1 minus 2 is equal to what? Y the negative 1. All right. So now the next things here we do is we will take the derivative of the dv. So we say dv dx. Okay, so the dv dx, so y the negative 1, if I take the derivative by the powers rule, will be what is negative 1 and the times, so negative 1 minus 1. So it will be negative 1, and this is y to the square. And then because we have a dy dx here, or if you want, you can write it as y to the negative 2 dy dx. All right, so this is the step number 1. So we will set a new variable v here. All right, so the step number 2 here, like we say, so this is step number, then the step number 2. So this is step number 1. Then step number 2 is let's replace the dy dx with the dv dx here. So dv dx is equal to negative y squared dy dx. So in order to find the dy dx, I can just do what? So I can just times the negative y to the square, both sides, right? So then this will be the negative y square dv dx. All right, so here, let me see here if I can get a different colors here. All right, so let's see here. Let me see, I can use different colors here. Okay, so maybe it will help to. So basically what I did here is I just multiply the both sides by what? By the negative y to the square, right? So here I times negative y to the square. So the left-hand side, so will be the dv dx times negative y to the square. And then this side, because this is a positive y to the square negative, so it's a cancel. So it's dy dx is equal to the negative y to the squares here. Okay, so now let's go back to what we did here. Okay, after I did this one, then I can substitute dy dx to my original equation. So dy dx, so this is negative y square. All right, so this is negative y square and dv dx, right? So then minus 1 over x y is equal to negative 1 over x cubed y squared. Okay, see here, I did not do anything here. The only thing I did is replace dy dx. Now I will single out dv dx. So what I need to do is here. So let me use different colors here. So that means now I need to divide by, or I will times negative y to the negative 2 on both sides here, right? So if you times the negative, so in here I'm times the negative y to the negative 2 on both sides here. So take a look. If you take a look at the first side, you know, the first item, so this is negative, negative, positive. So this y disappears, right? So you will have dv dx. Then the left here is the 1 over x, so minus 1 over x. Then y to the negative 1, y to the negative 2. So negative, negative, this one become positive. Then y over y to negative 2. So what here? This is 1 over y. All right. And then from my right hand side, because this is negative, negative, so this is a positive. So my x cube is still here, and the y square and the y to negative 2 become what? It's cancelled. So it's 1 over x here. And then take a look here. So 1 over y. What is 1 over y here? The 1 over y is here, right? So we said 1 over y here is y to the negative 1. So that's why I can replace this one to what? This one to this here. All right. Okay, so now so my differential equation will just simplify to the dv dx plus 1 over x to the v, then to the 1 over x cubes here. Okay, so now this is become our normal, like the first order linear differential equation. So what is the next we want to do? The next we want to do is to find the integration factors here. So here we said here, so this is step number 3 here. Okay, after we do that, then we define the new variable is du d what? Du dx is going to be equal to my here this is my new px, right? So will be equal to the 1 over x, right? Times what? Times u here. All right, so this is my new px. When you take a look, so this is kind of my new px. Okay, so this is how we find the integration factors. Then you do the separation. So I say du over u is equal to dx over x. I move the x around, then you integrate both sides. What I have ln u is equal to ln x. So I can solve it. I will say u, I know, is equal to x here. Okay, so after that, then we can substitute, right? So the step number 4 here is we substitute back to my equations here, all right? So that means if you remember the steps, right? So here we substitute this one u equal to x and substitute back to this equations, right? Okay, then let's see what happens here. Okay, so here, let's see here. So you substitute back, so you will get x times dv dx. Not a substitute, basically you times the u in this equation. Plus, now when the x times 1 over x is cancelled, so only have v, then this is 1 over x cubed, you times x. Okay, so it's 1 over x squared. So this is you multiply u on both sides of the equation here. All right, so you have here, and then we know this one's here. So now you integrate, so we know this one's here. This number's here. Let's see here. So we know this one's here is what? This one's here. This will be our kind of applying the product rule since here we will get okay, so here, let's see here. All right, so now let's so here we can apply. Okay, so here this is the one. We go into this one's here. Really is just what? This is just the x times v, right? So basically it's the product rule. So this is d to the dx x times v. And I know this one going to be equal to 1 over x squared. All right. So now I can integrate. So number 5, integrate both sides. All right. So integrate both sides. So my left-hand side will just be xv and equal to 1 over x squared. So this will be the negative 1 over x plus c here. Okay, and now I can, so what is xv here? What is the v? Remember, v is 1 over y, right? So I will get x of y is equal to negative 1 over x plus c. Now, my initial condition is y1 equal to 1. That means when x equal to 1, y equal to 1, right? So now I can say here, this is 1 over 1 is equal to negative 1 over 1 plus c. So what is my c value? I can get c is equal to 2. So now I finally solve my problems here. So I will have xy is equal to what? Negative 1 over x plus 2, or you can say this is x, and so this is 2x minus 1. Now you times divide the x both sides. All right, so divide the x both sides, and then you will get 1 over y is equal to x squared, 2x minus 1. All right, and now you flip, right? So that's why it turns out to be y is equal to x squared and 2x minus 1. See? All right, so this is what we solved, the if your differential equations, and you can change it to become by using the Bernoulli equation format, and then you'll be able to solve it. All right, that's it, and hope this one will help you to practice the Bernoulli equation, use the Bernoulli equation concept to solve the differential equations here. All right, we'll talk to you on our next problem solving section. Okay, bye.